Welcome back, Bafundi. Let's summarize what we have already learned. Have you seen that the steps of the scientific method are, firstly, observation, which generally leads to the asking of a question. Question is then followed by research, which leads to the formulation of a hypothesis. An experiment that needs to be designed and then conducted. So what happens next? Let's look further at the scientific method. While the experiment was being conducted, the scientists must make very careful records of all the results. Very careful record keeping when recording data is important for valid results. You could record measurements or take pictures or make diagrams of what you observe. Once the results have been recorded, they must be organized in a meaningful fashion. Charts and tables are excellent ways of organizing the data. After you've organized the data, you can begin to analyze the data in order to see if there are any patterns or trends in the results. You can also look for answers to your questions in the data. Graphs are excellent ways of displaying data so that it can be analyzed and interpreted. Ngamanye amaxesha, sometimes you'll need to perform certain calculations, such as averages or percentages, in order to analyze and interpret the data meaningfully. If you think about our example of the effect of temperature has on dissolving sugar, you would have probably made measurements. How much sugar was dissolved at each temperature? You could organize your results in a table such as this one. For each temperature of water, you could show the average amount of sugar that dissolved in that volume of amanzi, water. In our next lesson next week, we will look at ways of displaying data in graphs and analyzing and interpreting different graphs that life scientists tend to use. It is not sufficient to just draw the tables or graphs. You need to interpret the results carefully in logical, well-written paragraphs. Now remember that your results are not valid if they are based on opinions rather than data. Your results also are not valid if you make them up or change them to suit your purposes. Your results are not valid if your experiment was not a fair test or you did not have a control group to make comparisons against. In the next step of the scientific method, you are going to draw conclusions based on your results. Your investigation will not be valid if you draw conclusions that do not logically follow from the evidence or if you overgeneralize your results. Once you have recorded and analyzed your results, you are now ready to move on to the next step in the scientific method: conclusions. When you draw conclusions, you make deductions based on the results that you have just analyzed and interpreted. Your conclusions are drawn when you compare what has happened, that is, your results, with what your original research question and hypothesis were. You need to refer back to the research question you originally posed and show how your results can be used to answer that question. You also need to refer back to the hypothesis and show whether your results support the hypothesis or not. In your conclusions, you need to say why or why not the question can be answered and why the hypothesis can be supported or why it cannot be supported. Your reasoning is very important, Bafundi. Useful questions you can ask yourself to help you write your conclusions are: did my investigation answer the question? Did I find a solution to my problem? Was it as I thought it would be, or are my results surprising? Thinking back to our example of the water and dissolving sugar, what could we conclude from these results? Now remember that you posed the original question of, does temperature affect how sugar dissolves? And stated the hypothesis as, more sugar dissolves in hot water than in cold water. Well, these results certainly do show that temperature does affect the amount of sugar that a particular volume of water can dissolve. From these results, you would be able to say that your experiment shows that your hypothesis is supported. More sugar dissolves in water that was heated to 90 degrees. Another important part of writing up conclusions is evaluating your investigation. After having done the investigation and thought about what you did, you are now in a position to think about how you could improve your investigation, how you can make the test even more fair. Is there another way of answering your question more reliably? Could you have recorded your results differently to make them more accurate? If you did this in an experiment again, what would you do differently? What other experiments can be done further to test this problem? The evaluation section of their scientific report will help you and other scientists work more scientifically. So banana kakhona emva kwe break.